Thanks everyone for coming to this special edition of the Experiments Guild. So I'm really excited to introduce today Dave Caro, who works at Split. So Split's a startup company in Redwood City, and they started working on basically mechanisms for companies to roll out features gradually using something called feature flags. And they evolved into a company that's really got a focus on experimentation as a big part now, and A/B testing. And they work with companies like Qantas, Twilio, GoDaddy, Salesforce, all to help them with their continuous delivery and A/B testing mechanisms. So Dave Caro's role takes him to meetups, to different clients, to meet with larger companies who have built out really scaled platforms. And he's got a great understanding and knowledge base from all these different companies and people that he's met with in the industry. And so he's here to share with us today some of these core principles about experimentation, design, analysis, and execution that he's learned from this. So with that, everyone, please give a big hand to Dave.
Thank you. This is working, yeah? Great. Yeah, so my official title is Continuous Delivery Evangelist. So it's really people who want to move faster and be safe and learn, right? So I put together this talk because I know there's a wide range of people. Some of you would probably consider yourselves like full-time experimentation people, and some of you would be people who use experimentation platform from time to time, and some of you would be people who are sort of just, wonder what they're talking about, right? So my goal is to leave you with some key things to watch out for, because with great power comes great responsibility. That was actually another title for a similar presentation we gave in Europe recently. So let's jump right in. So here's what we're going to do. I'll very quickly cover why would we experiment, and then why sweat the details, and then we'll do the core of the talk, which is really the principles, and then some wrap up and Q&A. So why experiment? How effective are we at moving the needle? There are stats out there. This is one of those scary ones, which was Ronnie Kohavi, and you guys actually, I believe some of you met Ronnie here, another meetup. In a paper he did, he quoted 80 to 90% of the stuff they do doesn't actually accomplish what it's supposed to do, right? So we built this feature because we wanted to accomplish X, and 80 to 90% of the time it doesn't move that needle or makes things worse. And in a world where you're not doing experimentation, you might not notice. You think, well, we got that done and we got that done. And you sort of check off the boxes and feel like you're making progress. So being able to see whether you're making progress not as good. There's some other fun ones. So who here has heard the term HIPPO? Highest paid person's opinion, right? So there's a great article from, by the way, you're not related to Thomas Crook, are you? Yeah. Okay. So a great article, the HIPPO syndrome, and who ultimately decides whether a feature is successful. So anyone want to quickly guess who really decides whether a feature is successful? This is kind of a paradigm question. Well, it's the users, right? It's not anybody, right? So there's the quote here: some designers and managers have attacked A/B testing because of misconception that testing somehow replaces or diminishes design. Nothing could be further from truth. Good design comes first. And I was at a meetup last night where somebody said, yeah, you're a product manager and you said you ran this experiment. Didn't you involve design? And it was kind of funny because, well, of course she did. She has a team that has designers and coders and testing people, and they put a lot of effort into setting up their experiment with a new design. This isn't about not doing design. This is about actually figuring out whether your guess about what's going to work is actually going to make a difference. And I thought this was great. The key is that the end users are the final arbiters of the design success, right? Whether they use it, whether they do what you want them to do is actually what matters, not whether you think you did a good job, right? And A/B testing is the instrument that informs of their judgment. So this is why we do experimentation, is to actually figure out, are we moving the needle? Are we actually, does the thing we think we should spend time evolving, is it actually going to help or not? So then comes this: why sweat the details? So if some of your metrics look better, doesn't that mean you've done everything's great, right? Well, the problem is that it's pretty easy to be fooled, which is why I came up with the title of the presentation about how to avoid lying to yourself. So when I say we want to avoid the cost of false signals, this could be opportunity cost. It could be literally money you spend on whatever you're doing, just waste of time and energy, right? You don't want to spend time. So we want to avoid the cost of false signals. So just a quick terminology thing. Many of you may know type 1 errors and type 2 errors, a statistical thing. So a false positive, I like this because it helps you understand what these, I always get them confused, to be honest with you. I'll swap false positive, false negative, right? But this really helps you if you just remember this. If a doctor says to a guy, you're pregnant, That is clearly a case of a false positive. He's not pregnant, and the doctor says he is. And in this case, the doctor to a very pregnant woman says, you're not pregnant. We don't want that to happen. We don't actually want to think we move the needle and have not moved the needle, and we don't want to move the needle and not realize we did, right? So that's one of the reasons to sweat the details. The other one is this, which is a little scarier, which is we want to avoid the cost of human bias. This is pretty insipid and pretty nasty, and it'll kind of come back again and again, which is if you go looking for what you're hoping to find, you'll quite possibly find it, right? Which doesn't mean that it's there as much as it's not there, it's just that you were looking for it, so you found it. I hope that doesn't sound too like out there. So here's a chart with 180 forms of human bias. The really obvious ones you'll hear would be like observer bias, or there's survivor bias, which is a different thing, which is that if you only sample people who made it through your funnel to a certain state, then you're looking at the wrong population if your goal is to affect how new visitors behave, right? But observer bias, the idea that you go tease the data to find the thing you were hoping was going to happen, well, that's not the same thing as having a disciplined way to approach it, right? So the good news is that, controlled experimentation done well removes external influences, whether those external influences are sort of seasonality or other stuff that's going on or advertising or whatever, or be your own influence. By external, they mean external to the user interaction, not to your brain. So that's the good news is that there's ways to overcome this. So the fact that there's random noise and stuff is actually, life's like that. Life's bumpy. Life's not like perfect on-off states, right? So there's always going to be some randomness. And if you thought that flipping a coin 1,000 times would give you exactly 500 heads, well, most of us probably wouldn't think that. You think, well, it's going to be close-ish, right? If it doesn't come up exactly 500, that doesn't mean it's biased. So so stats is basically trying to make science of how do we figure out when it's meaningful and it's not, right? And how do we figure out if it results big enough to rule out variations in noise? Okay, so the stuff I just covered here is pretty much. Did I lose a clicker? Oh, that's interesting. Pretty much just background. Most of you probably know most of what I just told you, right? I just want to make sure that we're kind of starting from the same place. So let's get into the meat of it. So I'm going to use an example throughout here. Aiden gave me some awesome advice, which was don't necessarily use a Pinterest example because you guys probably know more about Pinterest than I do. I think I love the little bits of wisdom Aiden throws out there. That was one of those sort of blinding flash of the obvious. I was like, good point. So this is an Airbnb example. And in this case, what they want to figure out is if they have, they're trying to sign up new hosts. They're not trying to sell people on staying somewhere. They're trying to sell people on being a host, right? And they've got two variants. One is currently there's no video, and they think if they add a video from hosts, people will say, wow, now that I've met these people and I understand the benefits they get out of doing this, I'm going to feel more inclined to be a host, right? So we're going to step through then the design, execution, and analysis. And most of it's going to be in the design part, and that's kind of one of the big takeaways we'll have. So have an explicit hypothesis, choose metrics with care. I'm going to go into these in detail, by this is a preview. Perform power analysis to determine the time needed to hit the traffic goal, and consider business cycles seasonality. There's going to be, I believe, 10 core principles in here. So here's the first 4. And let's jump in and see what we're talking about here. And by the way, why are we doing this? Well, because we want to prevent after the fact fitting in the data. So if you just run an experiment, which is you try something, and then after it's over, you start looking to see what you learned. Again, the problem is that the likelihood of human bias kicking in is super high. So first one, explicit hypothesis. And I'm highlighting the word explicit because people say, well, we think blah, 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 blah. And depending on how you approach this, how disciplined you are and where you work. I've talked to shops where they have to be super crazy. They have like a very detailed document they have to fill out. And I've played in places where people have like one line in a form somewhere, like, what are you trying to figure out? So there's a guy named Craig Sullivan, probably at Skyscanner, because this is where the next little bit's going to come here from, came up with a sort of a simple way to do a hypothesis and then a more advanced one. And it's simply like, because we already have seen something, because we've seen something in our business, we expect that if we change something, we'll cause some impact, some desired impact. And we'll measure this using some metric, right? And that's the basic one. This one's a little more useful, which is because we saw a mixture of qualitative and quantitative data, we expect that if we change blank for population blank, it'll cause these impacts. And we're going to notice this when we see data metrics change over a period of this much time. Now, this one is way more useful. This one is still actually way too fuzzy, because if you don't set the time, if you don't actually know exactly what you're going after, you're more likely to cherry pick the results. So if we put that in here, we'll do like a simple version of the hypothesis and a better one. So because we see potential hosts aren't aware of their level of control when they're running their own property, we expect that adding an informative video will provide reassurances leading up to more signups. People will be less stressed about it. And we'll measure that using this metric, the proportion of users who sign up as hosts. What's the problem how many people use Airbnb and what do they use it for? Who here has ever used Airbnb? Right, okay, how many of you host a property on Airbnb? Yeah, right? So that's a pretty flawed metric. So the better version is like this. Because we actually did a survey which showed that potential hosts aren't aware of their level of control, we expect that adding an informative video just for Canadian users, because that's the one they're going to focus on for now, will provide reassurances. We'll measure this using a metric, proportion of users who visited the host homepage who sign up as hosts. Much better funnel, right? So people who go look at the idea of being a host, we want to see what proportion of those sign up with this on and off. And we expect to see an increase of 5% in the host page conversion rate over a period of 2 weeks, right? So just a better example of hypothesis. Here's where the meat of the talk is. And I'm actually going to go into like subsections of this one. This is the stuff that hopefully, even if you consider yourself like really into this experimentation, hopefully you're going to see at least one thing in here where you're going to be like, I probably ought to pay a little more attention to that. Good metrics, I was going to turn this into an acronym like MUDs or something, but they're really in an order for a reason, which is that they need to be meaningful. So the metric needs to actually capture business value. It can't just be a random thing like page views in a vacuum. So some actual, got to capture business value or something about customer sat. And then it should be sensitive, which is if you're running an experiment over a 2-week period of time, you can't go with lifetime customer value as one of your metrics. Right? How are you going to measure lifetime customer value in a 2-week window? You can't, right? So you have to find a proxy for something that's desirable, right? So it has to be sensitive enough to move, and it has to be directional. So it has to be it can't be going all over the place and have nothing to do with, if business value is higher, the metric should move up or down, but it should be consistent. It shouldn't be like, well, it could go one way or another and it doesn't really mean anything. And then the last one is kind of actually crazy important, which is it should be understandable by business executives. So it's hard to make a case about what you've just accomplished if the people you're explaining it to think it's some random or hypothetical thing that they can't relate to, right? So now we get into the more fun examples. So beware of focusing on the wrong metric. So you did meet Ronnie Kohavi. I don't believe he brought up this example when he was here, but they had a goal, which was, hey, we want to maximize the number of queries run per user. And this isn't what happened right away, but over time, the whole team was trying to figure out, how do we get more queries? How do we get more queries? How do we get more queries, right? And so what they did is they added these easy query refining links down here, and they added these easy related query links here, and they started filling up the page with ways you could get another query run quickly. You ever seen this kind of stuff on Google? No, and what they realized was that they were getting more queries, but they were cluttering up the interface with these. They were basically gaming it. They were trying to find ways to get more queries, but users don't come there to do lots of searches. They come there to get something and leave. And so they had to totally change their North Star metric away from queries per user into returning visitors. Because they want people to come back to Bing because it was so useful, not they want people to spend, have 10 queries in one session because they're, poking around, right? So it gets a little weirder. Has anyone heard of this one before? What's on my screen? What's blocking the shoe there? If you're looking at your phone and you saw something like that, what might you think you're looking at? Especially if you have black hair. All right, so this team basically put the image of a hair over the shoe, so people would, I've got to move the hair out of the way, right? So lo and behold, they were able to achieve more swipes, right? But they weren't measuring whether people were buying the shoes, just whether they got a swipe, right? So they could say, we're heroes. where at point you'd be like, oh, that was deceitful and annoying. I don't like that company, right? So that's filed under kind of the lure of winning, right? And this is a blatant case of gaming it. And we'll get to another, when we talk about metrics a little bit in another slide or two, we'll see another example of something. But so in this case of Airbnb, they wanted, the key metric was proportion of users who visited the homepage who sign up as hosts. Straightforward. Anybody can understand that. It's a proxy for a lot of things, which is your goal is to convert people to sign up. Now, maybe you'd also want to track whether those people actually ever rented their property the first time or something, but that'd be hard to measure in a short period of time. So that was what they settled with. So here's where we get into some other kind of crazy examples. Beware of measuring just one metric. So has anyone heard about this example? So the New York Police Department said, we're going to have a system that's going to keep statistics and it's going to help us do a better job of policing. And so they wanted to, the problem was that their one metric was reduce reported crime. So is the police's job to reduce the number of reports for crime or maybe to reduce crime, right? So if you look at what happened, and this unfortunate topic, but this is the thing that gets most attention. This was the reporting of sexual assaults, right? And if you look at, here we are in 1998, and yeah, it seems like it's getting better and better and better. The problem was that, so this was one of the police sort of leaders, not an executive, but an actual policeman's union person. How do you fake a crime decrease? It's pretty simple. Don't file reports. Misclassify crimes from felonies to misdemeanors. Undervalue the property lost to a crime, so it's not a felony. And the worst part here, particularly insidious way to fudge the numbers is to make it difficult or impossible for people to report crimes. In other words, make the victims feel like criminals so they walk away just to spare themselves from further pain and suffering. So the expectation is that the underreporting is like 2, 3x, 4x. Right? So the stats got better, but they got better because the entire organization was incented to make sure people didn't report crimes, not to reduce the actual incidence of things going wrong. And this is too much text. Basically, they realized, the commissioner realized afterwards that they were ignoring the measurement of our core functions and they weren't paying attention to the highest priority, public satisfaction. So they were stuck on one metric that didn't actually reflect what their charter was. So who has heard the term guardrail metrics? Okay, cool, great. So the idea for guardrail metrics, for those who haven't heard it, is just I'm going after metric X, like this case, the Airbnb people are trying to get more hosts to sign up, but I also want to make sure that I don't crater other important stuff. I want to make sure that I don't introduce errors. I don't want to add latency to the page. I don't want to have people unsubscribe to something, right? So guardrail metrics are things you want to watch alongside your key metric so that you don't, and again, you can get kind of fixated. If you're a team, you have a job, you're trying to make something better, right? So I would call that the local optimization problem, that your incentive is to make something happen, but you shouldn't slow down the page for all users just in the effort of getting more clicks or something, right? So guardrail metrics are kind of other things you should be watching while you do your experiment. And this one's interesting. And again, I think there's a fair number of you who are into stats, so you know, so the more stats we put up and look at, the more likely one of them is going to flash a false positive. So if I have a 5% chance of a false positive and I put 20 metrics on the screen, show of hands, or no. So how likely is I'm going to get, right? If I got 20 of them and it's 5% chance, well, one of them is going to be totally random nature. It's going to come up positive. And it's sort of okay to have them up there, but it's really important to not say, look, we improved that. Like we were going after this and this, but we didn't change that, but we did improve this thing. So if you're looking at too many things, you can actually, again, be subject to bias. You can basically gravitate on something that's not statistically valid. So this is an example just with numbers. So the chance of a false positive with a 5% chance, when you've got 2 metrics, it's a 10% chance. It goes up and up, right? And if you get to 10 metrics, we're already up to 40% chance that you're going to think you won when you haven't. Right, so it's important to focus on key metrics and not be deceived by thinking that you've moved something else randomly and that you're. And I hope this doesn't sound depressing. Like one of the takeaways from experimentation is it can be kind of hard, and you often won't actually crush it. But that's why we get good at doing this and try to do it as often as we can. So so if you're going to have a lot of metrics, then you want to tighten down your confidence level, which means you need more power, and we'll talk about power in a sec. Or you want to retest something which you thought looked interesting, create a new hypothesis that if there was that one box that turned green or whatever, and retest that as its own experiment to prove that it's true. So it's amazing how many times people won't actually do power analysis. They'll just run some sort of a test of some sort of size, and if some of the metrics look interesting, they're kind of excited. But you need to actually realize how valid is your data based on how much traffic you're going to send through. And if you're working with your home page or your start of your app, you've got a giant population. If you're working on an obscure feature that's 3 clicks down somewhere, the number of people that pass through there is probably much smaller, right? And so you need to focus on, if you just want to make sure that you understand the minimum likely detectable effect. And it's really the main inputs are how many people are flowing through this and how variable is how much variance is there in the data, right? How random and bumpy is it? So I just think some pictures help this, which is here's an example of a sample size of 1,000 users. And in this case, the minimum detectable effect in changing a metric is 6.27%, right? But if I have 100,000 users passing through, the minimum detectable effect is 0.63%. So I can have a tiny little lift in something, and it's valid. I can actually trust it. But if I'm only going to put 1,000 people through an experiment, I've got to make a huge difference. Otherwise, I'm just playing around in this area of could be totally random, not actually, hey, we made a 5% improvement. Well, that's actually not valid. That doesn't mean anything. If the 5% boost with that population is within the realm of nothing happened. You guys probably don't fall prey to this, but business cycles, you probably, I don't know what is interest, are we heavier? I actually don't want to weave any specific proprietary stuff in here because I want to keep the recording. So anyway, think about if you're, last night we had Tinder on stage, and Tinder probably is busier towards the weekend than they are on Monday morning. Right? And so depending on, you don't want to run your experiment for 3 days, or there could be a news event that happens in the middle of a 3-day experiment, right? You need a little more time to make sure that you're not being, that you're not missing out on something. So just take into account what is the likely seasonality, and hopefully you have a lot of analytics on what your customers do and you know those patterns. Just be sure to zoom out and make sure you're not running an experiment that spans kind of odd events or doesn't capture. So typically 2 weeks is good because you got the weekends and the weekdays, depending on what your model is. It's usually pretty good, right? So then we're almost kind of, so I apologize, the numbers are restarting. They'll be legit on the next slides. I couldn't get Google Slides to actually restart my numbers or keep them going. So when you're running a test, who here knows that peaking is bad? Okay, and I think we know peaking is bad because if you peak, you're more likely, again, human bias, you're more likely to, if you see something you like and you're not really through the interval you thought you were going to go through, you're going to go, ooh, look, it's awesome. Let's quit the experiment. We've already proved our point, right? But so there's a weird thing, which is that you want to be able to you do need to monitor for big degradations, but you don't want to peak or cherry pick the outcome, right? So real simple, data flow is just, I've started my experiment, am I getting data? If I'm going to wait 2 weeks, I better make sure that I'm actually getting data. I don't know if this has ever happened. I don't think I want to know the answer. But if you've instrumented and you've goofed somewhere, like one of the issues, if you read the Microsoft papers they write, they had a lot of issues early on with instrumentation wasn't what they thought it was. And so they would run an experiment and they didn't have the data they thought they were going to get. Right? And so they had to put a lot of time into that. And then randomization. So SRM stands for sample ratio mismatch, and we'll talk about that in a second. So super basic thing. I know this is crazy, but don't just hit go and then be disciplined enough to walk away for 2 weeks. You need to make sure that the data is flowing. And then make sure randomization worked as targeted. So this is a screenshot out of Split's product, which is, hey, you were going for 50% on and 50% off. And right now we're seeing 50.34 and 49.66, and we're doing the stats on that and saying, you know what, that's fine. You're flipping the coins and they're the way they should be. So have some way, whether you have to do this by hand or whether you have it in your system or whatever, just have some way to basically calculate whether the targeting worked out like it should. Because if you're off by a lot, then there's something else biasing your data. And again, we're always trying to remove bias, right? So have a way to check for sample ratio mismatch. And then this is that tricky thing, which is monitor for big degradation. So you don't want to freak out about minor changes in what looks like the business outcomes, as long as they're not drastic, but you should be looking for crazy stuff like errors, out of crazy latency, et cetera, right? And you want to catch that, but you don't want to peak, right? So if you're peaking, this is an example of a p-value that's changing based on how noisy the data is, and it changes, and everything was kind of lining up and there wasn't much variance here, and so it looks like you're doing really well. But over the course of the experiment, basically the data was pretty noisy, and so you have to kind of, you don't want to come in and say, wow, everything's super consistent and we're winning, and quit. And then the last thing I want to get into is analysis, right? So this is a problem that we see over and over again, which is that people will look at metrics without considering p-value or any other measure of how valid that metric is, and saying, look, we're 5% up or we're 10% up, like it's green, we're great, right? And maybe it goes without saying, but you really have to make sure that you're looking at both things. You've got to look at not just what the metric on the dashboard's telling you, but can I trust that metric, right? And then don't go digging for insights, except to formulate a new hypothesis. So after you've done your hypothesis and you're running your experiment, either during or after, don't go poking around to figure out whether you were successful or not using metrics that weren't in your original plan, except to say, oh, that's interesting. We weren't really looking for this, but I think that's interesting, and then formulate another experiment. Yes, it takes another cycle, but the problem with actually digging and finding something that looks compelling and saying that's a win is that, again, you're way too much subject to human bias. So this was a slide my colleague put in here about flipping a coin, and this is just for, again, this was kind of this slide was really intended for people that aren't really that familiar with statistics, which is, if you flip a coin 100 times and you get 45 heads and 55 tails, that's a fairly reasonable outcome. But if you get 10 heads and 90 tails, that's so unreasonable that that the coin is corrupt, right? But there's still a 32% chance, this is a 30% chance of being okay. But you have to calculate this stuff, whether it's built into your system or whether if you don't stop to realize what this raw number that the dashboard's showing you means, then you're really not doing an experiment. So in this case, the Airbnb people had their cohorts go through here, and they calculated, and then the p-value is 0.012283, which is pretty awesome. That's basically a little bit more than a 1% chance that they're getting that the findings they got were only due to random nature. So it's pretty solid. I don't know what you guys use for stat sig. 5% is pretty typical, but when people have super high numbers, they typically will even go for more tight ones to try to be really. The Microsoft guys are very, I don't know that it's amazing to have the system they have, but they're so rigorous about what they do that might be kind of frustrating, I would think. Oh yeah, great, you proved that, super. Just repeat it again so we can be really sure that you proved that. And I think I'd go a little crazy. So the last thing is that it's okay if you don't get stat sig and get something directional. Just don't consider it enough of a signal to make big changes. But you've basically gotten some input, and then this is where I'm pointing out. Don't dig for insights except to formulate a new hypothesis. So if you want to dig through the data, that's great, but be sure you're doing that as a research project, not as a way to save your experiment. Like if your experiment showed that nothing happened or that you couldn't have conclusive evidence, don't go looking for things that you can say you just proved. You can go looking for things, but make sure you do that to formulate another experiment. So here's an example of kind of what you do with the results, right? So, hey, this is looking good, like huge impact, super low randomness to the data. Go for it, ramp that up and ship it out, right? Here's an example of, okay, very negative impact, definitely not due to random stuff, so kill it and iterate. And then this is the one that the people get a little more confused about, which is that it's not really statistically significant, but it's interesting, right? That's still a big lift in this number, but because it's about a 50% chance that it's not meaningful, you don't necessarily want to roll with that and say it's a fact. You probably want to find a way to prove it better. So you probably want to iterate. So I know that was kind of a lot of kind of high level stuff. my goal was to start a conversation about sometimes we get focused on how we run our experiments or some of the mechanics, and we don't think about these kind of core principles. So I'll just kind of want a quick wrap up here on some of the high level stuff, and then we can do a Q&A really quick. So sometimes we forget, like, yes, we're trying to be very smart and we're trying to build really good stuff. And an experiment is one of the ways we prove. Ultimately, if you sort of cheat or if you fudge the numbers or find a way to game the system, you're just delaying finding out whether something really works. The users are going to tell you eventually with their behavior. So let's just watch how the users vote with their actions rather than a focus group. And basically to get meaningful output, to actually have something you can take away and sort of take to the bank, we just have to follow a few principles. We have to follow a few core principles, and it might be useful to kind of remind yourself, like once a week or whatever. I don't know what interval would be for you, how often you're running stuff, but just like, hey, am I cutting corners anywhere here? Am I leaving myself open to getting kind of led astray? And the other takeaway is that if you do this stuff well, even if you don't win with stats, if you don't prove that you crushed it, if you learn something in the process, then it's a successful experiment. And I don't know what your batting rate is. I mean, like to hear Ronnie describe it at once they've optimized Bing, like the chance of them actually moving a needle with an experiment is crazy low. And so it's kind of like doing biotech research. You might work for 5 years and actually not have anything to show for it, and then one day you do something amazing. But the thing to remember is that if you're learning and if you get better at doing this reliably faster, then you are gonna move the needle. And sometimes it's hard, but it's worth it if you can get it done. So on that note, I'm actually going to switch into Q&A. Are the people remote able to ask questions, or how do we do that? All right. So apologize that was a little rushed. I knew we had 40 minutes to work with, and I reformulated my deck a couple of times in the last week, so I didn't have like a hard timing to work with. But hopefully that gets some thoughts going in your head here. Anybody have questions?
Let's just thanks Dave for an awesome talk first. Yeah.